Okay. So today the 6-5A notes are about identifying the domain of rational functions. So rational, again, meaning what? Fraction, yeah. So we're going to be dealing with numerators and denominators again today. The only x values that are not possible in a rational function, so in a fraction, are the ones that make the denominator equal to 0. Because can you have a denominator of 0? No, you cannot. You can't divide by 0. It's not possible. So anytime you have a denominator equal to 0, then that's going to be not possible. So this is denominator. So today, when we identify the domain, we're going to be looking for things that make the denominator 0, because we know that the function's not defined at those places. If you remember from the very beginning of Unit 6, rational functions look like this. So this is kind of a sketch of the parent function. Do you remember this? What is this called? It's not a, yeah, it's a hyperbola. Very good. This is called a hyperbola. So we know that the hyperbola is not defined right here. So it doesn't have a value where x equals 0. So the domain is all the real values, so all real numbers, but x can't be 0. Do you remember talking about that? And that's on the very first set of notes that you have for Unit 6. So we're going to be trying to find those places where x is not equal to something. But other than that, the domain is all real numbers. So that's our goal today. And I'm going to let you work on your homework also. So the steps to do that, to find the domain of all rational functions, first it says set the denominator equal to 0. But I actually want to change this because I don't want it to be equal to 0. I want it to be not equal to 0. Because I think that that'll help you keep straight in your head more about what the denominator needs to be. Well, you do not want it to be 0. So you're going to set the denominator not equal to 0. Okay. Then we're going to factor, if possible. So factor that denominator and solve for x. Whatever you get when you factor is going to be not part of your domain. So it's going to be all the real values for your domain except whatever you find. Okay, so let's practice finding the domain of the following rational function. So on number 1, do I care about the numerator? No, I don't care about the numerator. All I care about is the what? All I care about is the denominator. So my denominator is x plus 2. I need to set the denominator what? Not equal to 0. So x plus 2, I do not want it to be 0. Because if it's 0, then the denominator is 0, and that's a problem. And even though that equal sign is a not equal sign, I still want to solve for x. So how do I solve for x? I'm going to subtract 2. And 0 minus 2 is negative 2. So I just found out what x cannot be. If x is negative 2, negative 2 plus 2 is 0, and I'd have a denominator of 0, and I don't want that. So my domain for this hyperbola turns out to be all real numbers, except, so comma, what? X is not equal to negative 2. There you go. That's what we're doing today. So again, we really don't care about the numerator right now. We're just determining whether the denominator equals 0 at certain x values. So on number 2, what do I need to look at? The denominator. So if I look at the denominator, I've got x squared minus 4, and I need to set it what? Not equal to 0. You bet. Not equal to 0. And in order to solve for x, I need to factor. And I notice that this is a difference of 2 squares. So what does that factor into? It factors into 2 linear factors, x minus 2 and x plus 2. It's like taking the square root of both of those pieces and connecting them with one as a plus sign and one as a minus sign. So I have my 2 factors. And I don't want them to be equal to 0. So what do I do with each factor? set them not equal to 0. It's kind of like whenever I'm solving and I'd take each of these and I'd create a little mini equation. Well, now instead of equaling them to 0, I don't want them to be equal to 0. So x, oops. Ooh. So x minus 2 is not equal to 0, and x plus 2 is not equal to 0. So now I have two little mini equations. If x minus 2 is not equal to 0, what can x not be for this one? Yeah, because if I add 2 and add 2, I'm going to get that x cannot equal 2. For this one, how would I solve for x? I would. So instead of x plus 2 is not equal to 0, I would subtract 2 and subtract 2, and I would get that x cannot equal negative 2. So my domain for the hyperbola is this, right? All real numbers. Except I cannot have x equal what? 2 and negative 2. So x cannot equal, I'm going to put plus or minus 2 because that covers both signs of the 2. Okay. Is there anything that you want to ask? How do you feel about that? Can I see a thumb? Pretty easy. Can I see your thumbs? Some tired thumbs going on in here. Okay. All right, so going on to the next group. On number 3, I want you to circle the denominator. I want you to create the equation. Circle the denominator, create the equation. Okay, turn to the person beside you and show them your equation. Make sure that it matches. Wow, yeah, okay, now y'all compare. Oh, what about this one? So, is that right? No, that's right. That's not right because it's the what? This is the numerator. I do not care about the numerator. I do care about the denominator though. So x squared cannot be 0, correct? Well, I can't really factor x squared. I mean, I guess I could, x times x. But how do you really undo a square? So if you square root the left side and you square root the right side, you get x is not equal to what? 0. Yeah. X just can't be equal to 0. So what is my domain? Except x cannot be equal to 0. I agree. Okay. So I'm going to skip down actually to number 5 because this is the last one that I'm going to do with you. And then number 4 and 6 I'm going to leave up to you to do in your groups. So number 5, if I don't want the denominator to be 0, I'm going to take this denominator, pick it out, and I'm going to set it as being what? Not equal to 0. Agreed. We did, because I'm going to let you do 4 and 6 by yourselves. So yeah, we skipped those. We're just jumping to 5. So if I'm going to try and solve this for x, it's a trinomial now. So what does trinomial signal in your head? Magic numbers. And so if I'm trying to think of two numbers that multiply to be 3 but add to be 4, there's only two numbers that do that. 3 and 1. So my factors are going to be x plus 3 and x plus 1. That product cannot be equal to 0. So each factor cannot be equal to 0. I get to set up my little tiny equations. So I've got x plus 3 can't be 0. And I also have what else? X plus 1 cannot be 0. So according to this equation, what can x not equal? And according to this equation, what can x not equal? -1. So your domain is all real numbers, except when x is what? -3 and -1. Oops, x not equal to -3, x not equal to -1. So I want you to take a moment to talk to your group. If you have any questions, try to get them clarified. And then numbers 4 and 6 are what I want you to be working on together with them. Okay, so walking around, things that I saw the right answers, but sometimes, like, if you took x minus 1 and you set it as not being equal to 0, and then you got the x was not equal to 1, sometimes when you wrote your domain over here, I saw this. What's wrong with that? It says x equals 1. I need x to not equal 1. That's the one place out of the entire hyperbola that if I had an x value of 1, 1 minus 1 is 0, and then I'd have a denominator of 0, and that's not good. So make sure that whenever you write your answer, that your x values are not equal to whatever makes the denominator 0. And then on the bottom one, this looked identical to number what? Number 2. Yeah, so if I rewrote this as a difference of squares as being not equal to 0, here x would not equal 2, and here x would not equal -2. So when you rewrite the domain, it looks exactly the same as the previous problem. So all real numbers, except x cannot be positive or -2, right? Okay. So